So here we're given a two-way contingency table with whether or not a person is armed when they're shot fatally and their race or ethnicity. And they also gave us the totals already to help us out. Now it does say write your answers as unreduced fractions, so I'm not going to reduce anything. The first question is find the probability that this person is unarmed. Well, how many unarmed people are in this table? 128. So it's 128 out of the 1424. Next, it says unarmed or white. So there are a couple ways we can do this. We can look at all these unarmed people or white people right here and find all those and adding it together. But there's a nice rule that helps us out. The OR rule is where we can add them together, but then if there's anything that's being double counted, we subtract it out. So that would be the probability of unarmed plus the probability of white, and then minus the probability of unarmed and white. So let's see, how many unarmed people are there? It's 128. And we're adding this with all the white, which is 732. But then we find that these 50 people, they're in both the white column and also the unarmed row. So these are being counted in both of these totals. So that's again why we have to subtract it out. So minus the 50 because they're counted twice. Now it's only counted once. And this is again out of the 1424 because we're looking at everyone here. And if you do this, we should have gotten, let's see, 810 out of the 1424. Next on letter C, it says unarmed given black. So now we have to consider the denominator changing because now we're only looking at people that were black. So we can ignore everyone else in this table, but we're only looking at these people right here. So let's find the probability that someone is unarmed. Well, how many out of all the black people, which is 380, how many of them are unarmed when they're shot is 50. So there's our answer. Now here we're back to, there's nothing that's given to us, so this is still all out of all of the 1424. We're not limiting it. It's not giving us someone to look at. And we're just looking at black and unarmed. Well, black and unarmed, how many people are there? There's these 50 right here, right? These are the people that were both in the black category and the unarmed category. So it's 50 out of the 1424. So that's all we had to do for the probabilities. I know one thing for the and is sometimes people think it's the multiplication rule, which you could use the multiplication rule, but when we have a table, it's very easy to see that these are the people that are in both categories. Now, if you wanted to use the multiplication rule, you would have had to use the probability of the first thing times the probability of the second thing, given that the first one was already found. So this would have been probability of black would have been 380 out of the 1424. And then here, unarmed given black, so this is out of only people that are black, as 380 out of only those 380 people, we see that there's 50 of them that are unarmed. And so when we use the multiplication rule, we see that at least actually that those 380s cancel out and you get the same exact answer. So it's a lot simpler though of just understanding what it's asking for versus having to just automatically go straight for one of the probability formulas. But it's not that it doesn't work, it just makes it more complicated, but you still get the same answer. So now, let's look at these next two to make sure we understand the idea of independent and mutually exclusive. And so if we're looking first for independent, remember what the formula says, which was actually on the formula sheet as well. We have the probability of A has to be equal to the probability of A given B. So all this is saying is that if we were to find the probability of A and then find that same probability again, but give you additional information about the other one, it shouldn't change. It should stay the same because that's saying that B does not affect your probability of A. And so we could have done this in a couple ways. We could have found that the probability of black is equal to the probability of still being black, but knowing the fact that they were shot while unarmed. Or we could have even done it the other way around, which is probably the easier way. because it doesn't matter which one was which. If black is independent of unarmed, then unarmed is independent of black. So we could have done unarmed. It has to be equal to the probability of unarmed again. But given that we're only looking at someone who is black. And if we do this, we actually realize that we calculated those two probabilities already. We found that unarmed was 128 out of 1424, and if we turn that into a decimal, we get about 0.0809. And if we do probability of unarmed given black, well, we found that, which is 50 out of 380. We get 0.13. And we notice, oh, are these things the same? No, they're not. Right? In fact, we notice that when it's given that it's a black person, that probability that they're shot while unarmed is actually higher. So it changed. It affected it by knowing their race or ethnicity. And so what we get is that these are they independent? No. Because, and you can just state that. Probability of unarmed is not equal to the probability of unarmed given black. You could have also been a little bit more detailed. You could have said, oh, no, because the probability of being unarmed changes when we know that the person is black. Or you can say the probability of being unarmed goes higher when we know that the person is black. So because of that, when you're given that information and it depends on their race or ethnicity, then it's dependent, not independent. Now for letter F, this one you could have done this a couple ways, just using again the definition, the probability definition, which is the A and B has to equal to 0. Or you could have just said, is it possible for both of these things to happen? Well, can you be white and armed while being shot? Well, yeah. In fact, there were 659 people there. So since both can happen, they are not mutually exclusive.